Good morning, class. Today we will be talking about Module 1, Lesson 1 in the 4th quarter of Grade 9. And this topic is all about uniformly accelerated motion. But first, let's have a review of what we had last previous grades. So these are the terms that you have already encountered in Grade 7 and in Grade 8. We have motion, uniform motion, distance, displacement, speed, velocity, acceleration, and constant acceleration. For motion, motion is the change in the position of an object with respect to the reference point. While uniform motion is when a body covers equal distances in a straight line, equal intervals of time, example, a car moving 20 kilometers per hour in a straight line. While in non-uniform motion is when a body moves in a straight line but with variable or change in speed. Now here's the difference between distance and displacement. First of all, distance is a scalar quantity. Scalar quantities are quantities with magnitude but no direction. It refers to the total length of path traveled by a body. Let's take for example this figure. So from point A, a boy rides his bicycle up to point B, and the total path covered from point A to point B is 4 meters. From point B, he moves to point C, and it covered 3 meters. Now, if you sum up that path from point A to point C, you will have 4 meters plus 3 meters, you have 7 meters. Now, that 7 meters is the distance covered. Well, the displacement is a vector quantity. When we say vector quantity, is a quantity with magnitude and direction. Refers to the shortest distance between the initial position and the final position of a body. So from point A to point C, you draw a straight line, and in the figure that is 5 meters. This 5 meters now is your displacement. And take note, since it's a vector quantity, it has a direction. So the direction would be northeast. So the displacement is 5 meters northeast. So that's the difference between the distance and displacement. For speed and velocity, speed is a scalar quantity. It refers to the rate of distance traveled by a moving object over time. So speed is symbolized by letter S. S is equal to d over t, wherein d is the distance traveled divided by the time taken in traveling that distance. Next, we have velocity is a vector quantity, meaning it has a direction, which refers to the rate of displacement of a moving object over time. So velocity, we have to divide the change in speed over the change in time. So the delta here, the triangle symbol, is called delta. It means change. So your velocity is equal to the change in speed over the change in time. The units used, we use kilometer per hour, meter per second, centimeter per second. So those are the units of speed and velocity. Acceleration refers to the rate of change of the velocity of object with respect to time. Now, acceleration could be positive. Okay, you could be accelerating because you're speeding up, or it could be also what we call as deceleration, when the object is slowing down, and acceleration can also be obtained when the body is changing direction. Uniformly accelerated motion, or UAM, is a constant acceleration, means velocity changing at a constant rate. Example, if a vehicle maintains a constant velocity in a given time interval along a straight line. So the units for acceleration are meter per second squared. If a body maintains a constant change in its velocity in a given time interval along a straight line, then a body is said to have uniform or constant acceleration. Let's take for example this car. It's in uniform motion if it moves 10 meter per second for the succeeding time. Now for obtaining uniform acceleration, it has 10 meter per second, 20 meter per second, and 30 meter per second time interval. So the change in the velocity of the car for each time interval is increasing, thus it is moving faster and faster This means that it is increasing its acceleration. For to determine the equations of uniformly accelerated motion, by the way, UAM or uniformly accelerated motion has two dimension. It has horizontal dimension and vertical dimension. So we have different equations for that. Equation number 1, we have Vf is equal to Vi plus At, wherein Vf is the final velocity, Vi is initial velocity, A is the acceleration, and T is the time. For equation 2, we have D is equal to Vit plus 1 half At squared. So the distance, I mean the displacement is equal to Vit plus 1 half At squared. That is for equation number 2. For equation number 3, we have Vf squared is equal to Vi squared plus 2Ad. And equation 4, displacement is equal to Vi plus Vf over 2 times the time. Okay, let's take for example this problem. An airplane from rest accelerates uniformly on a runway at 5.5 meter per second squared for 20.25 seconds until it finally takes off the ground. What is the distance covered before takeoff? So the first thing that you need to do in answering this problem is to write down the given. So we have the given are initial velocity, since the airplane starts from rest. We have 0 meter per second as initial velocity. Okay, remember that. If there's a term from rest, automatically the initial velocity is 0 meter per second. For the time, we have 20.25 seconds. And acceleration is 5.5 meter per second squared. Now, the unknown, or what we are required to solve for, is the distance, or the displacement rather. Formula is VIT plus 1 half At squared. Now, we are going to substitute the given in the formula. So, the distance is equal to Vi is 0 meter per second times the time, which is 20.25 seconds. Automatically, any number multiplied by 0 will become 0. So, if you multiply that 0 by 20.25 seconds, then that is still 0. Plus 1 half, 5.5 meter per second squared, that is the acceleration, multiplied by the time, 20.25 second, but the time should be squared, right? So, you have 410.06. Saan ang galing yun? Yung 20.25, in-square natin siya. So, ibig sabihin, 20.25 times 20.25, the answer is 410.06. Now, kasama nyo ring i-square is yung kanyang unit. Since we have here square, S, or second, should be squared also. So, you have 410.06 seconds squared. Okay? Next, the next thing that you need to do is to multiply 410.06 seconds squared by 5.5 meter per second squared. Okay, ang una natin gawin is i-cancel out natin yung magkakaparehong unit. So, we canceled out second squared. So, ang natirang unit is meter. Next, the answer is 2,255.33 meters. Now, it says there 1 half. Okay, 1 half of 2,255.3. So, we are going to divide that by 2. So, our distance now is equal to 2,255.33 meter divided by 2. The answer is 1,127.67 meters as the distance taken by the airplane before it takes off. Problem number 2. With an initial velocity of 5.6 meter per second, a car accelerated at 8 meter per second squared for 10 seconds. What is the distance covered and the velocity of the car at the end of 10 seconds? Again, you start down with a given, right? So, your initial velocity here is 5.6 meter per second. Bakit 5.6? Kasi wala namang nakalagay dyan na rest. Starts from rest. Wala. So, meron talaga tayong initial velocity. So, 5.6 meter per second. And then, yung time is 10 seconds. Acceleration is 8 meter per second squared. Malalaman mong acceleration yan kasi yung unit niya is meter per second squared. Kapag acceleration, naka-squared po yung time. Unknown is the distance and final velocity or the VF. Now, to compute for the distance, we will be using the second formula, VIT plus 1 half AT squared. And for the final velocity, we'll be using equation 1, VI plus AT. Substitute now, we'll solve for the distance, VIT plus 1 half AT squared. So the distance is initial velocity 5.6 meter per second times the time, which is 10 seconds. The answer is 56 meters. So na-cancel na natin doon yung second, no, na unit sa velocity at saka yung unit sa time. So 56 meters na lang yan. And then we have 1 half 8 meter per second squared times 10 second squared. So, ang gagawin natin, i-square muna natin yung time. So, 10 times 10 is equal to 100 seconds squared. And then, 100 times 8. And then, again, cancel the same unit. Cancel second squared. We have the unit meter. So, we have 1 half, right? So, 800 divided by 2. The answer is 400. Yung 400 na yan, ipa-plus mo dun yung 56 na nauna nating na-compute. Okay, so we have 56 plus 400. The answer is 456 meters. That is the total distance covered. Next, we have the final velocity is equal to VI plus AT. Your final velocity is your initial velocity is equal to 5.6 meter per second plus 8 meter per second squared. That is your acceleration multiplied by the time, which is 10 seconds. So, multiply nyo muna yung 8 meter per second squared to the time, which is 10 seconds. So, cancel niyo yung second, no? Isang second lang yung cancel. So, may matitira pang isa. So, 8 times 10 is equal to 80 meter per second. Ipa-plus nyo yung 5.6 meter per second. So, the answer, final velocity is equal to 85.6 meter per second. For problem number 3, a jeepney from rest accelerates uniformly over a time of 3.25 seconds and covers a distance of 15 meter. Determine the acceleration of the jeepney. So, the given is initial velocity is 0 meter per second. Remember, nanggaling siya sa rest. Huh? And then, we have distance is equal to 15 meters and the time is 3.25 seconds. So, the acceleration is the unknown. Formula is, we are going to use equation number 2. D is equal to VIT plus 1 half AT squared. Substitution, D is equal to VIT plus 1 half AT squared. So, we have a value for the distance. We have 15 meters is equal to 0 meter per second initial velocity times the time of 3.25. Of course, that is equal to 0, right? Any number multiplied by 0 is equal to 0. And then, we have 1 half A. A is still A because it has no value multiplied by the time, 3.25 second squared. So, i-square nyo muna yung time. Yung 3.25 times 3.25, ang sagot is 10.56. The unit now is second squared. Okay? So, you have 15 meters. Okay? Pwede nyo na alisin yung 0 kasi wala nang value yung ano na yun, yung part na yun doon. 10.56 second squared divided by 2. Divide nyo muna yung 10.56 sa 2. The answer is 5.28 second squared. And then, nandun pa rin yung A na unknown. So, para matanggal yung ano niya, para ma-solve yung A, you need to divide both sides by 5.28. Okay? Para ma-cancel yun, matira na yan sa equation na yan is letter A. A is equal to 15 meters divided by 5.28 second squared. The answer is 2.84 meter per second squared. Problem number 4, a train accelerates at a speed of 20 meter per second over a distance of 150 meters. Determine the acceleration of the train. So, you have the given, initial velocity is equal to 0 meter per second. Final velocity is 20 meter per second over a distance of 150 meters. Unknown is acceleration. Here, we are going to use the formula Vf squared is equal to Vi squared plus 2AD. Hindi natin pwedeng gamitin yung D is equal to VIT plus 1 half AT squared. Hindi pwedeng gamitin yon. Kasi una sa lahat, wala tayong acceleration. And wala rin time na given. So, magagamit lang natin yun. It's either, kapag merong time, no? Makakompute natin acceleration. Hindi kasi pwedeng dalawa yung nawawala sa isang problem, no? Mahirapan tayong isolve yun. So, we will be using this formula. So, substitution, we have Vf squared is equal to Vi squared plus 2AD. We have a value for Vf squared that is 20 meter per second squared is equal to initial velocity of 0 meter per second squared Okay, 0 times 0 still 0. So, we have 2a, 150 meters. So, multiply mo muna yung 150 meters sa 2, which is 300 meters, and then times a. So, we have 400 meters squared, second squared. Bakit naging meter squared yun? Kasi naka-squared po yung ating final velocity. So, pag naka-squared yun, i-square natin, hindi lang yung number, kundi pati yung unit. Kaya naging meter squared yan. Divided by second squared is equal to 300 meter per 300 meter times A. So, ang gagawin is i-divide both sides by 300 meters. Why? Para ma-cancel out yung 300 meters sa side ng A at ang matira na lang doon is the acceleration. So, you have acceleration is equal to 400 meters squared, second squared, divided by 300 meters, cancel meter, may isa pang meter na natira, so the answer is 1.3 meter per second squared. So that is the acceleration of the train, 1.3 meter per second squared. Next, as I've said, UAM or uniformly accelerated motion has its vertical and horizontal. So we're done with the horizontal dimension. Now we will proceed to the vertical dimension. So gravity is a force that pulls objects to fall. It causes an object to fall toward the ground at a rate of 9.8 meter per second squared. Stone drop from a certain height, that's what we call as free fall. So free fall yung hinayaan mo lang siyang bumagsak, no? Kapag kasi may force ka na kung saan binato mo siya pababa, ay may initial velocity na yun. It's no longer free fall, no? And then we have this one, okay, stone drop from a certain height, free fall by 2 seconds after falling, its velocity is 19.6 meter per second. So by 3 seconds, it is 29.4 meter per second. So this 9.8 meter per second is what we call as acceleration due to gravity. So it was found out through experiments that objects fall at that rate, no? Whether it's heavy or light, as long as they are in a vacuum. Pag sinabi nating vacuum, yung walang air. Kasi 'di ba, pag nag-drop tayo ng dito, halimbawa sa labas ng bahay niyo, nag-drop kayo ng no, nag-drop kayo sa let's say sa terrace niyo or sa second floor ng bahay niyo, nag-drop kayo ng feather at saka ng ball. You drop them at the same time. Mapapansin niyo na mas unang ma-reach ng bola yung ground kaysa dun sa feather or balahibo. Bakit? Kasi merong air resistance na tinatawag. This air resistance is isa siyang force na nasa air na pumipigil doon sa pagbagsak, no, ng mga freely falling bodies. Now, in a vacuum, pag sinabi natin vacuum, walang air, if you drop them at the same time, they will reach the ground at the same time also at the rate of 9.8 meter per second squared. So without air resistance, objects whether light or heavy thrown at the same time will fall at the same rate. So here in this equation, we also have equations for vertical dimension of UAM. We have equation 1, VF is equal to VI plus GT. Okay, para sa halos yung ano niya, yung A lang is napalitan ng G. G is the acceleration due to gravity. So equation 2 is H is equal to VIT plus 1 half GT squared. Equation 3 is VF squared is equal to VI squared plus 2GH. Equation 4 is H is equal to VI plus VF over 2 times the time. So, the distance here was replaced with height or the H. The initial velocity is still the same, BF is still the same, A, acceleration. Acceleration, actually, that's already G. Acceleration due to gravity. And T is the time. Okay, so number 5 problem. Z is playing with a ball on top of a building but the ball fell and hits the ground after 2.6 seconds. What is the final velocity of the ball just before it hits the ground and how high is the building? So if here the given, kung mapapansin nyo sa given, 2.6 lang yung given. 2.6 seconds, that is the time, right? But there are hidden given. Mga given na hindi na in-state dyan, pero automatically, because they are constant. Just like the acceleration due to gravity, that is 9.8 meter per second squared. Naka-negative lang siya because the direction is downward. Imagine that the ball is going downward, going toward the ground of the building. So the direction is downward. That's why it's negative. For initial velocity, that is equal to 0 meter per second. Kasi kusa lang naman nalaglag yung bola, no? Next, we have unknown. what we are going to compute is the final velocity. Gaano ba kabilis yung bola bago siya na-reach yung ground. And then, how high is the building. Okay? Next, the formula to determine the distance or the height is VIT plus 1 half GT squared. VF, or the final velocity, is equal to initial velocity plus GT. So, yung D natin, pwedeng H din yan, no? Hindi ko lang napalitan dito. So, anyway, they are just the same, no? Next, we have final velocity is equal to VI plus GT. So, substitution, we'll just compute first for the final velocity. So, VI is equal to, VF is equal to VI plus GT. Our VI is equal to 0 meter per second plus negative 9.8 meter per second squared times the time, which is 2.6 seconds. So, cancelled out na natin yung 0 since 0 yung ating initial velocity. We only need to multiply negative 9.8 meter per second squared doon sa 2.6 seconds. So, cancel na natin yung isang second. May natira pang isang second. So, the final unit is meter per second. So, negative 9.8 times 2.6, the answer is negative 25.48. That is the velocity. Walang square dyan ha. That is the final velocity. VF lang yan. VF. Hindi natanggal yung squared. Next, you have the height of the building. The height is equal to VIT plus 1 half GT squared. Okay? So, the height is equal to 0 meter per second times 2.6 till 0 yan. 0 yung magiging sagot dyan. Next, we have 1 half negative 9.8 meter per second squared times the square of the time, 2.6 second squared. So, if you get the square of the time, you will have 6.76 seconds squared. Now, multiply that by negative 9.8 meter per second squared, you have negative 66.25 meters. And then, divide nyo yan sa 2 kasi 1 half. The answer is 33.13 meters. In terms of the height, wala tayong negative na height or negative na distance. It's always positive. Okay? So, that is negative, the height is equal to 33.13 meters. So, that is that is all about uniformly accelerated motion, discussing the horizontal and the vertical dimensions. Thank you for listening and good day.